employed at DRW for the past 10 years. I don't know if John has mentioned DRW, but we have a lot of, we have a great relationship with Code Platoon. We've got 2 people on my team who are from Code Platoon right now. There's another guy across the hall who's hired full-time, Brian Maloney, out of Code Platoon. I come here and talk about Git and HT, and later on I think I'll be talking about HTTP with you guys as well. It's been a great relationship, and I really enjoy Git. I enjoy sharing what I've picked up from Git. I've been a kind of a source code control professional for about 20 years, so I learned enough to get my job done. And doesn't mean you can't stump me pretty easily with Git, because you can. But I hope today that I can help you to I don't know if fall in love with it's the right word, but use it, because it's out there so much, and it is actually very, very handy as a kind of a basic, like a hammer for a carpenter. It's very, very fundamental to anything you do with code, or even any other sort of artifacts that you would use. We have networking people at DRW who use it for their networking configurations. They're not developers, but they still find it useful because they do version control on their stuff. So so how much exposure have you guys had to Git up to this point? Like you're in week 3, is that right? Have you used Git?
We use Git to grab our class assignments and then put them back.
Okay. Are you doing any sort of collaborative work on stuff right now, or just mostly sitting in class doing exercises? And
we have, like, so that we don't override the master, that kind of thing. Like we've done that, I think, once or twice.
Okay. Any Git merges?
We rarely do the merges, but we went over it once.
Okay.
In a pairing session.
Okay.
Where one person would we would create a conflict on purpose and see what would happen.
Okay. Okay, so you've seen it, at least seen what a Git merge is. And okay, I won't actually be doing much with that. I could if like somebody wants to specifically go over it in some context. You will need to use it down the road when you do collaborative work. I think if I could just put this out in front of you right now, if you can find a way to begin using Git as you go through the class. I know you've got a lot coming at you right now, so it would be a challenge to actually fold that on in, because there's a lot to learn just in Git itself. But if I can, we've got 2 sessions here, so if I can, in those 2 sessions, bring you to a point where you would feel somewhat more comfortable doing that, it would bless your path down the road. So, for instance, if you were able to do that, you would not have to drop into an internship or a first day on the job and have to stumble through how to use source control, because most likely they're using Git, and most likely they don't want to teach you Git. They want other stuff from you, right? Than having to teach you Git. So if you can put that into your, even if your individual versioning, locally, even aside from pushing it up to GitHub or wherever, you can be comfortable with using it to manage your own changes. That would be huge. I do that myself. I mean, I've got lots of little sort of side projects I work on, and I just want to maintain a known good point. Sometimes I want to try stuff, but if it all goes south on me, I want to get back to where I know something works, and that alone is huge. So, if you can begin to fold it into your individual workflow, then you'll have 50, 60, 80% of what you need to use Git effectively in a team as well. So, all right, so let's have your environment set up. When you guys set up a Git repo, do you use HTTPS or do you use SSH?
I think HTTPS.
Okay.
clone it and copy it. And put it
Okay, so we'll do that today. It's easier because you don't have to know about SSH keys and all that.
What's the difference?
So it's the protocol that you use. So if we look at, I'm going to hide this here, but I didn't want to hide that. Okay, so I'm in a Git repo here. Can you guys all see my screen? Anybody cannot see my screen? Okay, I think we're good. So my current directory is this Git repo that I just pulled down. I'll have you guys do it in a minute, but if I look at what it is, what origin it's pointing to, so my repo is this, and the format of this line here is there's sort of a protocol at the beginning. So this, because you have user at host, that's an SSH protocol. It's a clue that this is an SSH connection. SSH is a secure shell, so you basically exchange keys with the remote end, and then the pipeline that goes between them is encrypted. So if somebody's listening in on that pipeline, they can listen in, but they can't understand what's going back and forth because it's already been encrypted on the endpoints. So
Are you referring to like a SHA key? Or
no, we will. That's not this. It uses SHA-like keys in order to perform the encryption on the endpoints. But the idea is that you know both ends can talk and nobody in the middle can understand what they're saying. So that's how you. This is basically a user at some host, and then something that you want to tell that user at that host. In this case, the host is GitLab. What I want to tell them is my my organization and repo, which is the GitHub format. So what you would want to do, and I'll just go ahead and do that because you guys can do this too. I'm going to remove that. Start over. You can type along with me after I do this removal. Okay, so let's pull down this repo. This is something you guys are all going to use today, so feel free to follow along with me. So here I am in the directory. I want to clone down a repo that we're going to use, and I'm going to use HTTPS. So you've seen HTTP. HTTPS is HTTP over SSL, which is similar to SSH in that it's that encrypted pipeline. So you exchange HTTP-like messages, but they're encrypted, so nobody can read what they are in the middle. HTTPS : / and then it doesn't have a user, at least in the format we're using. GitLab.com. This is another Git repo hosting organization. And then it's somewhat similar. There's the organization, which for me is just my username. And then the repo, learning-git-chris. I hit enter. Should be fine. So because this is a public repo, I don't have to authenticate. I've come in there anonymously in this particular command, so GitLab doesn't necessarily know who I am at all. But that's okay because on the GitLab side, I've made this repo public. So you can also have private repos, in which case you would have to tell them who you are. So we're good. So we can CD into here. Now I want you. Have you guys used? You talked about Bash profile at all in your environments, so you know what you put stuff in there. So I'm going to have you put some more stuff in there. You do an ls-la, -l for long and a for all, so that you can see your dot files as well as your other files. So there's .git, which is the Git repo, everything. It's the history and everything, the entire repo. There's this little sort of optional file called gitignore. We might talk about that later. Then there's this .bash profile. So let's use cat to look at that. Cat space .bash underscore profile. Have you guys used aliases in Linux or Mac OS?
A little bit.
Yeah.
Aliases are awesome. This is not Git. This is Linux, Linux, Unix, Mac OS. But you can define any shortcut you want. For Git, it's handy because there's a lot of goofy commands that they're not fun to type all the time. So Git checkout master, I like that one. GCOM is what I like to type instead. You can also tack on whatever you want at the end. So if you say GA for git add, you can say GA space and then something you want to add. So it just puts it together for you. So to put that into your current environment, you can say source space .bash underscore profile. Okay, so how do we know that it worked? We could say alias GA, for instance. It tells us what our GA alias is. So, yeah, that's a git add alias. You can do some, probably more fun one here is ADOG. Let's see if that works. You should get something like that, which is I'll go through that in a little bit here, but that's a history of this particular repo with all the nice decorated branches and merges. And then to get out of that, you can just hit Q for quit. It disappears. So our aliases are there. Let's go one step further and make sure that it's there not just for this session, but for your other terminal sessions that you bring up. So
what did you just say?
So I hit ADOG to show the Git repo history, and then you can arrow up and down, or if you hit return, that goes down as well. A space goes a page at a time. You can hit B for back, and that goes up a page at a time. Basically, the less, there's a pager called less in Mac OS and Linux, so it basically pipes all this output through less, and you can move around in it.
I know Chalua Akeb.
What's that?
Chalua Akeb, that's he's Nigerian, right? Nigerian. It's like a lot of book titles.
Oh yeah, this is a basically a dump of a Wikipedia article about cargo cults.
No.
Cargo cults?
Cargo cults.
Yeah, it's an interesting social phenomenon. So I just used it for text that we could generate a Git history from. But the Wikipedia article is cool too. So, but this less pager, you can look that up separately, do a man space less in your Linux environment sometime, and that's what's being used here. There's various commands like B for back, F for forward. You can search for stuff, and hit N for finding the next search, and capital N for the previous, et cetera, et cetera. So, and then Q to get out. You want to just exit out of that view. So back to putting your aliases in place in your bash profile. If you know that they're not there already, you can just redirect the contents of this bash profile. I'm going to type a little carefully here so we don't clobber your other one. So cat space .bash profile, and then type greater than sign twice. You type it once, then you might clobber your bash profile, but twice means append instead of overwrite. So 2 greater than signs, and then we point to our the one in our home directory. So tilde is an alias for, or another name for your home directory. /bash underscore profile. Whoops. PASH. Okay. So this will take the contents of the one that we have right here and append it on the end of whatever we tell it to at the end. And in this case, the one in our home directory. So in my case, I've already got it there, so I'm going to have to go back and clean it up later, but it doesn't hurt to find it twice. So just to emphasize, this would be wrong. You would probably not appreciate running that. So
What does cat actually do? Or what's cat?
cat is short for concatenate, so it just shows you what's in there. Yeah.
So we don't have the color scheme that you have, so is that a separate part of the profile?
That, I believe, is something to do with the terminal itself.
Okay.
Yeah. Terminal preferences. Yeah, I think I just chose this and set them like I like them. I probably used one of these and changed it around. My eyes can't handle brightness very well, so I make everything dark if I can, and on a dark background, bright text. Okay, so now you should be set up to use these aliases now and also later on when you close out a terminal and come back in later. Cool. So what are we going to use them for? So the format I think I want to take right now is just we'll spend another 35-40 minutes going over Git, and then we'll take a break, and then we'll get back into it. And that will be session 1, and then in a couple weeks come back and do session 2 and cover stuff that we haven't gotten to today. But today I hope we can I guess demystify Git a little bit. I don't know what you think about Git, but I thought it was pretty mysterious for several years until I actually had to teach this class, as a matter of fact. But it really isn't that difficult. It's the commands around it are difficult, but the actual model that it uses is very, very simple. So today, if we can learn the model, then we can separate the data structure and what Git is versus all these commands that surround it and manipulate that data. I think if you can get a handle on that, then you can really start to know how things ought to go and just chart your course for what you want to do with Git in a given situation. So for instance, let's go back to this. This is a very handy command. I use this all the time, and if you see the alias list up here, it's this alias. So it's just a git log command. -- all means show everything. In other words, all branches that are in play, and pointers, etc. Decorate, I believe, means to show pretty colors. One line means to show each commit information as one line in the history. You could show all kinds of different things in the git log, but this is just a concise way of showing it. And then -- graph draws the lines between merges and branches when you type it. So this is the graphical sort of representation of what's going on. So let's use this to define some terms. Actually, I better point with my pointer for the sake of our remote colleagues. Let's look at this line up here, top line. Okay. Anybody want to volunteer any information about what is that telling us? What can you tell from the top line about your Git repo?
It tells you the branch that you're in.
Okay. Which is?
In this situation, it looks like.
Make it larger.
It looks like you're in the master branch. The head branch. Oh, wait,
okay.
I can't see it actually. Oh, so so you're at the origin. You got me on that.
Okay, so master, yes, master branch. That's correct. So what is head then? What is that? Do you think?
It's like the key.
It's a pointer. All right, that's kind of what I think what this is getting at here. So head is a pointer to master. So head is this. It's kind of it can be a symbolic reference. We'll look at what I mean by that in a minute. Or it can be an actual pointer to an actual commit. And it's basically where your workspace is at any given point in time. your workspace that you see, in which you see the files and that you've changed or are going to change, it's backed by a commit somewhere that you are potentially going to add to, right, and move on in your versioning from that commit. So head is it's basically telling you this is the next thing, that this is what you're going to add to when you change stuff. If you commit stuff, this is the commit you're going to pop on top of. So go ahead.
So then the subsequent after the minus greater than sign there, those would, can you go over one more time what are those again?
Sure. So let's look at head a little bit closer. I'm going to come out of ADOG here and see where that's actually defined. So I said before that there's this .git directory. This is your repo. Okay, this is where all the versions are stored and everything that Git needs to operate is stored. So I'm going to cd into there, look under the covers a little bit, and oh look, there's head right there. So if you're wondering whether you can like look at a file, you can tell what kind it is by using the file command. So file head says that head is ASCII text. So that means I can cat head. And so head, it says, in sort of Git speak, is a pointer to refs head's master. And refs head's master is just a directory path right here. And there, hey, there's a file called refs head's master. Let's see what that kind of file that is. Well, that's just another ASCII file. So that means we can cat that one too. Oh boy, what's that?
Is that the encryption?
That is a SHA. So let's put that on our stack to be the next thing we talk about. but it's basically it's a reference to a commit. Okay, so head points to master and master points to an actual commit reference. So remember 1894. Okay, let's go back up and go back into ADOG. And okay, there that is. That's a shorthand. It's an abbreviated version of that SHA we just saw, right? So what we just saw was how head pointed to master. It's just a file with a name of a branch, and it's kind of a long name because the branch lives a couple directories down, but we call it master. That's fine. And master points to this commit. Yeah, that's all ADOG is doing. It's reading these files and it's stitching together a picture for us. It's represented by these files that contain the branch state and the state of your workspace. This stuff is similar. So as you know already, you've got your local Git repo, and you've also got a remote, or may have a remote, that corresponds to your repo. So if you see something like this in this history, those are branch names, and they are references to remote branch names. So what this says is you've got a remote called origin, and origin's master branch happens to point to the same place that your local master points to. So you could say that it's caught up, in other words, or that you're not ahead. You haven't gotten ahead of your remote because they're on the same commit. That makes sense. There's also origin has a reference to head as well. You usually don't care about that. You usually care about the branch that corresponds to your branch to see if those guys are in line. So, and then you've got off at the end, just to fill out the story, you've got the commit comment that went with that commit. So my last commit was to spruce up my alias list a little bit and add another version of ADOG, which tells me ADDOG, which tells me that my alias is wrong. Sorry about that. I've got a full path in my alias. So if it was working, if I didn't have this thing in here, it would tell me the date. This is a big long way to specify the date as one of the attributes of my commit line. So this won't take me long, I don't think. Let me just fix this for right now. EDOG, I can say that equals that, and then I just ignore everything before Git, and copy and paste, and maybe that will work. ADDOG. Okay. So now, basically all it does is gives me this date here now. 2017, October 9th, 9:43 p.m.
Can we get that copy and paste you just did there?
Sure. So all I did was I listed the alias, right? And then I said, well, most of this path for Git is wrong. I just need this part here that isn't. So then I just basically redefined my alias here. You know, I said, I want AD dog to equal this now instead of what it was before. And then I pasted, you know, the snippet in that I cared about.
And when you shut it, like what we did with the end, or like when you shut this off and turn it back on, it will have the date again. Because
it will not have the date.
but
It will still be wrong. So let's
append it.
I'll zoom through and fix it in my bash profile, and here's how you would do it. You would edit your own profile with your own editor, right? I'm going to use VI because that's my go-to tool. So here's all this stuff, and I would just go down to here, and I would take that out, right? And then now I'm good. Save that, and then to finish it off, I would now source it, which reads it again, and then it's all good, and it will be good from there on out, assuming my environment uses Bash. If it uses ZSH, I would need to edit a ZSH profile. But yeah, so that's a bit of a tangent. But so to pop the stack a little bit, we were going to talk about what this thing really is. Right. So that's a SHA. SHA is short for Secure Hashing Algorithm, I believe. And it's a way to generate, and this is key, it's a way to generate a random string from the content of something. So Git is founded on the principle that if you apply this SHA algorithm to a given piece of content, you'll always get the same thing. If you don't get the same thing, you know that it's not the same content. So this SHA here is basically generated from everything that goes into that commit. So we'll pick that apart. But the commit, I hate when it just disappears on me like that. Let me copy this. I'm going to copy this SHA abbreviation. And we can use a little command called git cat file, -p for print, and then we can pass it this thing.
I'm stuck here.
Sure.
I can't get out of your Bash profile. What's the key?
Were you in VI?
Yes.
Okay. You can hit escape once or twice to make sure you're not in edit mode.
Yeah.
And then colon, you want to write out what you've done or just quit?
I just want to quit. I don't want to change it.
Okay. So if you haven't changed anything, you can just go :Q.
Enter.
Enter. Yeah.
No right sense.
So you must have changed. So you can go :Q bang, or exclamation point. And that'll say get out without. I don't care. I don't want to save anything. That's what it says.
All right.
So So we've got this SHA that we've looked at, and now we're looking more closely at it. So this git cat file looks at the contents of a given SHA in Git, and this basically just tells you what a commit is. This is a commit SHA. So this is everything. I'm sorry. Is there really a % in there? Okay, maybe there is, but it's basically the content of what makes up a Git commit. So you can see it's got a few attributes we'll also go over. The author, the committer, the date, the parent SHA. So it has to be able to, to draw this history, it has to be able to point backwards. So that's what the parent SHA tells you. The tree is a kind of SHA that is it's like a grid cluster of files and directories. Right? It's what's going to come out when you check out something. It's all the files and directories. So Git takes all this stuff and runs this SHA algorithm on it, and it comes out with this unique identifier. And so that is a if it wasn't unique, Git wouldn't work. But because it is, it functions like an address at a post office. It's a unique address for this content, right? So if you've got this SHA, then you're always, this is the content that generates that SHA.
So it's like a key.
It is a key, yeah. The key is the SHA, and the value is the content that generated that SHA. So there's only 3 kinds of SHAs. There's the one we looked at, the commit SHA. There's also the tree, which is this kind here. The parent is just another commit SHA.
So it's generated every time you do a git commit, not a git push.
Correct.
Okay.
Push just exchanges SHAs and keys and values.
So if I do a commit working on a file and then I make my updates, do another commit, that'll be a different unique key.
Yes.
Okay.
And even if you commit the same stuff again, exact same stuff, remember it's the date is part of the content. So because the date's going to be different, you're still going to get a different SHA, even if the files are exactly the same. So you'll see, you'll see a different value for this. So there's the commit SHA, the tree SHA, and then there's also the other major kind is a blob SHA. That's just content of a file. So if we look at a tree, for instance, let's dig into this commit SHA and say, how about this guy? You can pretty much take any sort of unique snippet of this SHA and Git will understand, as long as there's nothing, if there's 2 SHAs that start with E7, then that's not good enough. But if you give it at least 4 characters, it's generally going to be it's going to be pretty unambiguous. So let's say git cat file p, and then we'll see what's in here. Okay, so this tree has blobs, and that blob is that 3rd kind of SHA, right? Just keep on digging. Git cat file -p. Let's see what happens when we the blob. Okay, so that looks a little familiar, doesn't it? That's our bash profile content. Now, if you look up a little bit here at this blob we just catted, so the blob is just the content. It's not the name, right? This line has everything a tree has. A tree has the permissions. It has, the type. It has the blob reference itself. It has what I'm going to call this blob. But when we actually looked at the blob here, right, it's just content. It takes the tree. The tree has to give it some meaning and some context. And here's the file name. And here's the permissions it has. So the blob is just the file contents itself. That's what a blob is. So all these use this SHA algorithm to do what they do, right? So a blob is a blob is generated by applying SHA to a file, and you get something out of it. A tree is generated by applying the SHA algorithm to all this, and then you get this out of it, right? And then if you keep going, you get the commit. Where's my commit? Too far. Yeah. So here's the commit, right? You apply the SHA algorithm to all this stuff, and then you get this SHA. So you don't have to know how that's done. Just the principle that it's unique, and that that's basically the data model of Git. You've got blobs at the lowest level. You've got trees. In this case, a tree can contain another blob, but in this case, it just contains. I'm sorry, a tree can contain another tree. In this case, it just contains blob. We don't have any subdirectories, in other words, in this particular tree. So if we did, we would see that one of these types here would be a tree, right? And then that tree would have its own references of trees and blobs. So blob, tree, and then commit. Those are the three types of SHAs that you'll see in Git. And that's pretty much all Git is at its lowest level. The complexity comes with all these commands that manipulate this stuff. But any command you run in Git is going to be manipulating this data structure, right? I mean, that's what it's doing. It's comparing different versions of these things. It's taking two commits and looking to find out how the graph goes back between them and what the differences are. You can use git diff for that, or git log to see how all the branches connect together, back in time. But it's just working with these three types of SHAs, right? So let's go a little. Let's see what's time we got. We got a few minutes here. Let's try to cover one or two more things. So terms, we talked about SHAs. The formal term for what Git is doing with these things is called a content addressable file system. So you've got the file system about on your Mac, which is files and directories and CDing around, and Git can produce that file system from what it has, but its file system is just key and value, right? SHA and content. That's all it's got. So if you want to get at something in a Git repo, you have to you have to say, this is the SHA, give me back what this SHA has. That's its address. And because that address is generated from the content, that's why they call it a content addressable file system.
And the SHA is basically created by the content anyway, so it's almost like saying, this is the content, give me the content, but we're just saying this is the content and look at different.
Right. Well, and if you have this unique value, it's handy, because then you know that if your content generates this value and that value is already in the database, then you can just use that one. You don't have to keep copies of it, because a given key always corresponds to a unique set of content. Now you can't go the other way. You can't take the key and generate the content, right? It's a one-way algorithm. But you do know that if you get two of the same, then that there's only one kind of content that can be on the other end. You don't have to reproduce it. You can just use it. So even if you if we came up with this file, this .bash profile completely separately, and knew nothing about this one, and it happened to be the same, and we checked it in, it wouldn't, it would already be there. So it would just use it. What? Come on, Java. So you have to play with it to appreciate it, but it's really brilliant. I mean, Linus Torvalds, who came up with Git, is said to have invented Git in a weekend. And he didn't invent Git in a weekend. He's incredibly bright, but he didn't. But he did come up with this data model in a weekend. Right? He came up with the essence of it. that's part of the brilliance of Git, is that it's actually very simple down at its core. So, and it's, if you work with other source control systems, it's also a whole lot more performant in most cases than Subversion or other systems that have a different data model. I won't go into that. Has anybody had experience with other source control systems? Otherwise, it won't. Yeah, it's irrelevant. But yeah, Git was addressing some real fundamental issues that you just couldn't use these. You couldn't use. So Git was to for Linus to manage changes to a Linux system kernel. And
Sorry, can you say that sentence again?
So Linus is he's the the originator of Linux. People contribute all kinds of stuff to Linux, like all over the world, all the time. Right? He has to integrate them or turn them back or change them and integrate them. And so he needed a system to manage all those changes to the Linux system kernel. So he invented Git for that, because he just, what was out there wasn't cutting it. So SHA kind of, okay, remote. We talked a little bit about a remote. Let's touch on that just a little bit here. I said Git remote-v a while back. So you've probably seen this, but you can have an arbitrary number of these remotes. That we happen to have one called origin. And that's sort of the convention. If you just have one remote, it's probably called origin. And that's the thing that you clone this repo from. You can also, of course, init your own repo and then just push it and define an origin and just push it out there to that destination. I am going to just show you an example of a repo that has multiple origins. Let's see, where would that be? It's okay. So here's a project I've been working on. I just bought a Nest thermostat, and it keeps history, which is cool, but it rolls off. So it only goes like 2 weeks back. So I'm like, it's my history. I don't want to lose my history. So I looked up the APIs, and I've got a Nest integration that hits Nest every minute and stores the current temperature, and so yeah. So this is my Nest repo. I can run adug on that, right? And now this has more than one remote because it runs on Heroku. So I've got my remote down here, right? That's out on GitLab. But now I've also got, I want to push it out to Heroku because Heroku is the one that actually does this ping of the Nest thermostat. And so the way Heroku operates is that you basically push a Git repo out to it, and it has stuff in it that it knows about, and it pulls it out and deploys your app out of your repo. So if I want to deploy to Heroku, instead of saying git push origin master, which is what I'm very familiar with doing, you'd say git push Heroku master, which I'll just go ahead and do just so you can. Okay, I can't do that because I don't have any changes. Let's make it work. So I'll put a change in here. Add a comment. Get out of there.
It's a CPU tip.
I'm sorry?
It's a CPU tip.
I'm sorry, I don't understand what you're asking.
I'm sorry. What temperature are you actually collecting here?
Oh, the temperature of my house.
Oh, so
this is like in my house. It's like the smart thermostat, and you could, it connects to my Wi-Fi and uploads stuff, and so.
It must be expensive.
So, well, ComEd gives you a $100 discount, and it actually it saves you more than the price of it costs. Like in the first year, it's pretty cool, and it tells you humidity and stuff too. But
and if you can do all this, I think it'll probably save you more. Really crunch the numbers.
I probably won't save any money at all from, but it's really cool. So I'll save money from thermostat, not from all the coding hours that I spent on this thing, but it's really cool. It gives me practice on stuff, right? So, all right, so I have, so notice I'm using my aliases to see where I'm at. I just tweaked environment.rb. I can use my GD alias, right, which is Git Diff. So I can say GD environment in environment. How come that doesn't work? Yeah. GD in V. Okay, is there really no changes? Oh, yes, okay. So the reason I'm not seeing any changes is because Git Diff, so we'll look at this in the next hour. Git Diff looks at what's in your workspace versus your index. So there's three trees in play in Git. There's your workspace, there's this thing you're about to commit, which is what's in green here, and then there's the actual commit that you're going to be hopping on top of, or I should say pushing on top of. So when I said Git Diff, there's nothing actually that hasn't already been added to the index. So it says there's nothing, there's no diff. So I can say, okay, well, fine. Let me look at the difference between what's in my index and what's in the Git repo, right? Index and head. So that's Git diff-staged. So that shows me more. So that's basically the difference between head and that stuff in green. What am I getting ready to commit, in other words? So so there's some stuff that I forgot to change all this stuff. Oh, okay. Let me just look at environment.rb. So there's my comment that I wanted to just add as a test. So I am going to, I think I can just go ahead and push this and I won't break anything. Let's try it. So git add same stuff. I'll probably undo this later. So now I've got a commit that is, so now I'm one ahead of Heroku, right? Also one ahead of Origin, but we're pushing to Heroku right now. So I'll say git push Heroku master. Now it says, oh, you've got changes. Let me go. So those SHAs went up to Heroku. Heroku pulled them in. Now it's checking them out into its own workspace where it's going to run my app. And now it's running this build that it does on it. This is all out. All this build stuff is outside of Git. That's Heroku. So, but here's Git stuff here, right? This is from here on down is just Heroku stuff. It's building my Ruby app out of bundled, install, blah blah blah. And so that's an example of a time when you would want to use a remote that's different than Origin. Long to make a short story long. So so Origin is just happens to be a convention for the remote that you generally pull from. Just you can call it anything, just as long as you're consistent when you use it. But Origin works. Let's see, anything we covered in the next 2 minutes. Are there any questions so far from what I've covered? Anything you didn't quite pick up, or that I lost you on completely?
I've got two things. So you said I missed part of it, but you said there's basically three things. There's your workspace, something, and the commit. Yes.
So workspace, index,
yeah,
and then the commit that you're working with, or that you're going to be pushing to when you do a commit, right? That's head basically. The thing that head points to is where what you started with, I guess is another way you could say it.
Okay.
When you did a git checkout, here's the commit you started with.
And then the index, what's the index?
So the index is the thing, when you say git add, that modifies your index, right? It's a staging area, another name for it.
Okay.
So it's what Git does to prepare to create a full-fledged commit when you're ready. So like if you say git add and you give some directory names, it's going to go ahead and actually create SHAs for that stuff, right? And get the SHAs ready. They won't be commit SHAs yet, but you do need blobs and tree SHAs, right, to be able to put in when you do get around to committing.
Okay. And then it's about to get ready to go to the commit area where it'll maybe become the new origin starting point or something.
Well, so what happens when you do a commit? You've got your blobs of trees. So if we look at let's look at our head commit right on here. Cat file -p for print. So a commit consists of the tree. So your index will have that. Your index won't yet really have a parent. I guess you could think of head as the future parent, right? I guess that means your index is pregnant with a commit. So you've also got the author. You've got the date, right? These are all things that have to get put together to produce a real bona fide, full-fledged commit. And an index doesn't have that yet. You haven't told it yet what the author will be or the date, or it thinks it knows what the parent is, but you could change that too before you commit. So what you do know, it is very handy for seeing what you're about to put into the commit, right? Because you can do the git diff -stage and stuff. Let's actually continue. I'll flesh out the notion of these three trees in the next hour here. But let's take like a 10-minute break and come back at say 5 or 7 after.